Alright then, hello guys. Today we're doing another CryptoHacks challenge, and the challenge we're going to be doing today is going to be called Modular Inverting. So it says right here, as we've seen, we can work with a finite field, adding and multiplying elements and always obtaining another element of the field. For all elements G in the field, there exists a unique integer D such that G times D equals 1 mod P. This is a multiplication inverse of G. Example, 7 times 8 equals 56, which is equal to 1 mod 11. What is the inverse element of D equals 3 to the power of negative 1, such that 3 times D is equal to 1 mod 13? Think about the little theorem we just worked with. How does this help you find the inverse of an element? So, they want us to find the inverse of 3 times D, 1 mod 13. So, what number multiplied by 3 gives us 1 mod 13? So that's the inverse they're trying to make us find. So how do we solve this challenge? So it mentions something about little theorem. So if we look up Fermat's little theorem, Fermat's little theorem states that if P is a prime number and A is an integer not divisible by P, then A to the power of P minus 1 is equal to 1 mod P, meaning that A P minus 1 divided by P leaves a remainder of formulated 1. So if A is not integer, if A is an integer not divisible by P, so if A is an integer not, so that if P is a prime number and A is not an integer divisible by P, so if, let's see, if P is a prime and A is not an integer, okay, so P is a prime. P is a prime, which is negative 1. From theorem number 3, statement for prime. Oh, mod P. So 13 is not. 13 is a prime number, and it can't be divisible by 3. So that means this theorem counts where it says A to the power of P minus 1 is equal to this theorem. So we could solve this simply with Python. So with power. So we got 3 to the power of, what's this? 13 minus 1 is 12. 12, and I think it's 1. I could be wrong. Oh, print. I think that's how you do it. I always forget. 0, 9, such that, so Fermat's little theorem then is equal to A mod P, which is holds its value as a multiple of P. So let's do the power. Python. You could take 3 values. Okay, a number of the base and option the modulus. So the modulus of that specific number. So from little theorem, let's go images. Fermat's little theorem. So okay, so I think it's 13 maybe. 12 at 13. 1. Nope. $13, 12. Oh wait. Fermat's little theorem. Fermat's little theorem is basically A to the power of P minus 1. P minus 1. That's what we have, which is then equal to 1 mod P. So A to the power, A in our case is 3, and then it's gonna be to the power of 13 minus 1 is equal to 1 mod 13, which is that equal to 3 to the power of 12, which is then equal to 1. And we have, I guess, this part, which is 3 times d equals 1 mod 13. So 3 times d is equal to 1 mod 13, I think. And we're trying to solve for d. So we replace 1 right here. It's going to be, I think, 3. 3d equals 1 mod 13, and we're still trying to solve for d. It says right here for Ohm's law theorem that 3, 12, and 1, 3d mod 13. Mod 13. We have that so far, which is, this is basically, because 1 mod 13, I think it's 1 mod 13 is basically 1. So it's going to be 3. 12 is equal to 1. Okay. So what if we put this inside this invisible one? Because this is basically divided by it's going to be 1 is equal to 1 to the power of 3 to the power of negative 12. And that's going to be 11. 3 to the power of 11. Oh, yeah, that's correct. Okay. Now we divide both sides by 12, so which is going to be 11 is equal to 3 to the power of negative 1 mod 13. So that basically means 3 to the negative 1 is equals to 311 mod 13. And this is going to be mod 13 as well. And from right here, we could basically do power of 3 to the 11th mod 13, which is this function right here. So we could just go like that. 3. And then that should get us the final answer. So if we run this, print, and if we run it, we should get 9. Now, if we compare this to our final solution, the flag was 9, so which is the final answer. So it takes, I guess, a little bit of understanding about Fermat's theory, in which we get this as one of our final parts. But after a bit of plugging in and messing around a bit with the math, you should be able to get this as a final answer. So yeah. Hope you guys learned something new today. I know I did. And I'll see you guys in the next one. Peace.